let us see some problems that may be asked in GATE. The first question, mostly the questions will be asked from viscosity. So let us see this question. When a flat plate of 0.1 meter square area is pulled at a constant velocity of 30 centimeter per second parallel to another stationary plate located at a distance of 0.01 centimeter from it, and space in between is filled with fluid dynamic viscosity of 0.001 Newton second per meter square, the force required to be applied is. So we have seen this type of problem in theory. Let us solve this. There is a plate and the area of this plate is, it is given as 0.1 meter square, and there is liquid and there is a stationary plate, and what is the data given? It is pulled with a velocity of 0.3 meter per second. 30 centimeter per second is equal to 0.3 meter per second, and the distance between stationary plate and movable plate is 0.01 centimeter, and this is 0.0001 meter, and the viscosity of the fluid is 0.001 Newton second per meter square. The force required. What is the force required? That is to move with a velocity 0.3 meter per second. So we know that tau is equal to mu into dv by dy. If the velocity profile is not given, we consider it as linear velocity profile. If a velocity profile is given, for example, if the velocity profile is parabolic, then we consider this way. So if no velocity profile is given, consider it as a linear one. And here the velocity is 0 because it is stationary one. Here the velocity is 0.3 meter per second. So dv is equal to v minus 0. The velocity is 0.3 minus 0, which is equal to 0.3 meter per second, and the distance dy is equal to, we have considered this as y-axis and this is x-axis. The distance of distance on y-axis of this point is 0, and here this point is 0.001 meter. So 0.0001 minus 0, which is equal to 0.0001 meter. And mu, what is mu? The dynamic viscosity is given as 0.001 Newton second per meter square, and also area is given as 0.1 meter square. So tau can be written as F by A. Force by area is the shear stress, mu into dv by dy. So force can be written as mu A dv by dy, and force is equal to, what is mu? 0.001 Newton second per meter square, and the area is 0.1 meter square into the velocity 0.3 divided by 0.0001 is dy, and it gives, if we solve this, we get 0.3 Newton as answer. So this is how we need to solve. Let us see another problem. So this arrangement is given. There is a piston and there is a lubrication of some oil of viscosity 0.9 poise, and the piston diameter is 19.95 centimeter and cylinder diameter is 20 centimeter. Let me write here, d naught, outer diameter, is equal to 20 centimeter. It is 0.2 meter, and di, inner diameter, is 19.95 centimeter, which is equal to 0.1995 meter, and the length of the piston is 10 centimeter. Here it is 10 centimeter, so it is 0.1 meter, and velocity is given as 0.5 meter per second. And what else is given? Viscosity is given as 0.9 poise. We know that 1 Newton second per meter square is equal to 10 poise. So 0.9 poise is 0.09 Newton second per meter square. We'll write all the units in SI so that it will be easy to calculate. And we need to find what is the force that is applied on the piston. So tau is equal to mu into dV by dy. First let us find the shear stress. We know velocity dV is equal to, the cylinder is stationary, so it is 0.5 minus 0, which is 0.5 meter per second. And dy, how do we find dy? Dy is the distance between the stationary plate and the moving plate. Here the stationary plate is the cylinder and the movable plate is this piston. This is cylinder 1 and this is pistons. So what is this distance? This is dy. So what will be the distance? 20 centimeter minus 19.95, which gives the distance, this distance plus this distance. If we divide by 2, we get dy, and we get it as 0.05 divided by 2, so 0.025 centimeter and 0.00025 meter. And next, if we substitute in this, we get it as 0.09 into dV. The velocity is 0.5 divided by dy, 0.00025. And if we calculate it, we get it as 180 Newton per meter square. Once check it, the calculation is right or wrong. And force is equal to shear stress into area. So which area we need to consider in this? The piston surface area, or the cylinder taking the diameter as 20 or taking diameter as 19.95. In any case, the movable plate or the movable piston area needed to be considered. So here we need to consider the diameter as 19.95. So what will be the area? The piston looks like this. So what will be this area? This area, the circumference area, is contact with the that oil or fluid, some fluid. So what will be that area? This is D and this is L. So it will be pi d will be the perimeter, and into length will give us area. So tau is 180 into area is pi into diameter, which is 0.1995 meter, into length is 0.1 meter. So if we calculate that, we get it as 1.128 Newton as answer. So the force that is applied on the piston is equal to 1.128 Newton. So these type of problems may appear in GATE exam and ESE exam. Solve more problems so that you will be perfect at any type of problem.